Here we go. Hello. I'm on time. How are you people today? How are you doing? I'm doing very well because I can concentrate on my passion project. And this one is a passion project. Where's my... Wait, why don't I... Let me show that. Yeah. Here we go. This is... I don't need a power bank here. This is what this is about. This mini console. And someone suggested Bad Apple. And we had like raw 16 by 15 1-bit frames stored. We have only... there's one bad pixel. We have only 14 kilobytes left, so the animation is quite limited. But am I streaming on Twitch as well? Yes. Twitch is live. Okay, all right. And then we went down the rabbit hole writing a compression. We didn't want animated GIF, since you need a lot of RAM for the dictionary, and we tried different things. ChatGPT made a tool to convert the frames. Here is what we have now. This is a Quadtree compression. That I don't know if there is like something comparable out there, probably, but I'm not so like keen to read about stuff. Just reinvent the wheel, and that's what we did. How that worked, that's the Quadtree. We also made a octree, but we don't have the decoding compression yet. We also tried run length encoding, which is like twice as bad. So we were only able to compress to 30%. This is already 18, and I think octree was able to compress down to 14%, which is really nice. And we are compressing the difference image only. So that's specifically for like animated 1-bit videos, the compression algorithm that we're talking about here. I have done a little bit work behind the scenes that I talked about yesterday, but I can maybe show how the Quadtree works. That's basically here, MS Paint. We divide the image, which is 16 by 16 in the beginning, so we ignore the last row, but we divide it, and then we have the difference compared to the image before. If nothing changes, then we have everywhere zeros, and you can imagine this is like pixel, and here is 1, here is 0. And Quadtree is basically a tree that starts like with one node, which is the complete image, and then it has 1 bit. Bugged out? No, Twitch chat works. Okay. I will greet you all in a second. Just give me the minute to explain how the compression works, the Quadtree. So we indicate a 0 if everything below that in the tree trunk is 0, then we have 0, and then we quit. Next frame. Divide and conquer, the same happens with since we have like a changed pixel here, this will indicate 1. This will indicate 1, this will indicate 1, and this is 0, 0, basically meaning all the pixels below are also 0 here. So everything that doesn't change, we can skip, and this way, this compression, is great to like, if something changes in a part of an image, it narrows it down to that section, and only stores the bits that are needed there. Everything else is basically skipped, which is really nice. That works well. We checked out here that shows for we extended it a little bit, so it's a lot. Okay, so if you look at a quad of 4 pixels that are next to each other, these are the frequencies how often such combination occurs. And if you see the difference image, basically nothing changes. 386,000 times nothing changes. So there is always a 0. So if you, I don't know if everyone is familiar with Huffman encoding. That's basically a binary tree or a tree. Yeah, you can. So what we utilize is like these distributions here compared to like this count is like very unequal. So we use just like you can abstract it as an Huffman encoding with 0 is basically compressed like to 1 bit and everything else is compressed to 5 bits because we have like 1 that indicates the tree below is populated, and then we have 4 bits for each of the corners of that section. So everything else is stored in the quadtree in 5 bits except for the 0, which is 1 bit. That worked well. We were able to compress down to 197 kilobytes to 35 kilobytes without any losses, which is cool. And you can see the comparison. This is the original animation, and this is the compressed and decoded image, which is basically identical. So everything works well there. And what I did since yesterday, I indicated it that we have we have still like a different distribution of probabilities of each of the things. And if you look at that, that's like 1 is basically encoded. That looks like, where do I, my notepad here. So we have like if there is 1 bit change, since we store the differences and we have a high frame rate, only like the edges change from frame to frame. So we quite often have only 1 or 2 pixels changing in a section of 4 pixels. So what I thought, maybe we can improve the quadtree by using a Huffman code for the last 4 pixels of the tree. So instead of storing always 5 bits if it's not a 0, we can maybe optimize that. And what I thought in that case is I sorted the probabilities. You can see 5,500 times on average we get all the combinations where 1 pixel changed, which is what we would expect. Then we have changes of 2 pixels is like almost 2,000 times, so even less than half as often we have the state where 2 pixel changes, and even more rare is like changes of 3 pixels. Where is it? There are some missing. Some codes are missing. Here you can see 3 pixel changing would be a 7. Oh, it's only like 383 or 450. That's like 3 pixels changing here. So this is even less often. So we could use Huffman codes for that, and the rarest is where all pixels are changing. That's basically if the image like switches from black to white. So this is the most. No, it's not that rare. Look at that. It's even. Oh wow, interesting. Maybe I should use a different code for that. However, I tried that, so we can store. This is like maybe a draft. We can use maybe 3 bits for storing that, and then 4 bits for storing combinations of 2 pixels, and then more and more bits. And since yesterday, I implemented the Huffman coding, and I will show you the result in the code. I tried like hard-coded. Oh yeah, this is the result of the Huffman codes that we can use for storing all the combinations, and the most common ones will be stored in 4 instead of 5 bits, which is unfortunately not that much of a saving. And then we have like the rare occasions we have even 6 bits, which is more than before, but that's like a rare. With the masters. Yeah, thank you, Hannes. Yeah, so we have sometimes even more bits than before, but very often less bits than before. But the 0 doesn't change. There's the... And here we go. The results, I calculated the savings. I didn't implement it. I just used the hard-coded Huffman codes, and we can save like 2 kilobytes on top of that. So that will be like only 5% or something. Yeah, 6%. So we can even go lower than to 33 kilobytes in that one. And then I also tried, oh wait, no, wait. This is a different Huffman tree. I think this was the result of this Huffman tree, which is even where I tried, okay, maybe we can use, I can show my notes on that here. So I manually try to balance the, this is not the face, here we go, face camera. Balance the tree and distribute the Huffman codes because I wanted like fewer bits, like only 3 bits for, but that's only possible for 2 of the codes. Here we go. So this is like 0 is always like 1 bit, and we have 1. 0, 0 is this set of pixels, and so on. And then it gets deeper and deeper, and then it equalizes somewhere here, which I try to redraw again in that case. And so I made this is basically the, wait, here we go. This is the optimized set of codes, optimized, but it only yields 2.1 kilobytes of savings, and the one that I did initially, which is even more balanced, but it's wasting 2 codes. We have 2 extra codes which we could use for a different state, like a really odd state. We could use the code which is 6 times 1, or the last bit 0. So we are wasting 2 codes, but this is still 2.2. We can show it if we use that. So let's compress. Yeah, 2.205 bytes that can be saved with the really flat Huffman encoding, which is okay-ish. But if you consider you have some extra effort with decompression, it's not that big of an effort. It's some extra code, because then during the decompression you will basically, you have another lookup table, that's all. But then you have a variable. You can do it with like maybe if nesting if you want. Otherwise, yeah, you have some extra code. So might be a good trade-off to get like another 6%. But what I wanted to do, okay, before we continue, that's the current state. We have the octree, which is even better. I will explain that soon. But I say a greeting. So hello Christian and Dutch Taurus and Bleep Track and Paulus and Hannes. Oh, and some lurkers. We have another 10 lurk 10 lurkers there. I greet you all. So I implemented, so this is hex tree, where you have a lookup for 16, yeah, here we go. So what we did now is let me clear that. We stored like the last 4 pixels, and we saw, okay, this is like the most common stuff is like 1 pixel is changing, and I thought, okay, maybe we can do even 1 level higher and store, like generate Huffman codes for a 4x4, and then we are basically, what we are doing then, we are moving away from the octree compression to an actual 2-dimensional Huffman tree, because now we need like the bigger dictionary, and this bigger dictionary for 2x2 is like 16 codes already, because you have 4 bits, but 4x4 is ginormous. So 4x4 is 16 bits, and that's like 65,000 3 here, this is the number 65536 different combinations in the Huffman tree. So that doesn't fit in our RAM unless we will generate the Huffman code. So if it's like an algorithm that calculates the Huffman code, that could work. Let's take a look at the probabilities. Yes, Huffman encoding. Hello, Atom Fighter. So the mini console is this 10-cent RISC here, which has a Charlie plexed 16 by 15 display, and we are trying to fit in the 14 kilobytes of flash the whole animation of Bad Apple, which are 5,000 frames. It's uncompressed, it's 200 kilobytes, so it's very challenging. We are down currently to around 30 kilobytes. So yeah, it's almost it's still a lot to do. Where's the Twitch chat here? Here. Okay. Yeah. So the results are currently, I made a Quadtree compression, and with on top, for the last 4x4 carats, 2x2 carats, we can save another 2 kilobytes of this. Yeah, 14 kilobytes will be challenging. So we have to go down to maybe like 10 frames per second, because this is now 30 frames per second, and then we benefit a lot that in the 30 frames per second, not many pixels change per frame, since we are compressing the difference. Border off pixels to make space. Oh, you mean, what do you mean, like crop? No. Yeah, no, it's already a low resolution. I guess we will sacrifice frames at the end, or maybe the run length. I don't know how much Bad Apple you can digest. So it's a quite long animation already, and I guess we don't need like the whole animation. Okay, so here are the probabilities for 4x4 pixels. And as you can see, hey Deshipu, yeah, it makes a huge difference. So if I use like this quadtree compression, which basically a 0 means nothing changes in the subtree, and then like for the 4 subsections we have an indicator what changes there and so on until the last pixels. It isn't able to compress anything, any saving. Like we have 106% when we have no difference, and if we use difference, not many pixels change, and that's where we can save, like compress down to 18%. So now we have I checked what we can do with another Huffman compression of the last 4 pixels, which currently now, if there is one changing pixel, it stores 5 bits, and we can reduce it to 4 bits and save 2 kilobytes on top, like to this 35. Then we will be down to 33. And now I was checking, okay, can we generate Huffman codes for 4x4 tiles? And this is the probabilities or the counts of how often something happens. And we have 83,000 times nothing changes in a 4x4 tile. Then we have 681 times 1 pixel changes. This is also 529. And not genius, this is just everything learned in not in school, in university or whatever, or it's just experience. Whatever. Yeah, we have, if 1 pixel changes, that's quite often. We see there is like it's 600 times around about. Yeah, that's what we do now. What we could do is we could save, maybe instead of doing a quadtree, just store for each frame. Let's say we have let's say 16 by 16, and we just store 1 bit for each 4x4, like a Huffman code. We can just doing the Huffman for 4x4 tiles, then we have 16 tiles, and if nothing changes, we have 16 bits. That's 2 bytes. Oh wait, how many bytes how many frames was that? We have 5,000 frames. Yeah, we now use like 5 bytes or something. We can use 2 bytes if nothing changes, and then we have Huffman codes for changing tiles. So we could try that, but my octree compression, if we can prove that it's able to compress down to 14%, that might be a better starting point. So the octree compression, now I need to explain what's happening there. Octree compression, didn't I have a second paint? Yes. So you can imagine if something changes in a frame, and we have, let's say here, the girl that moves around, and we have another axis which is the time. And the girl basically moves like a trajectory through space-time. Let's call it space-time. So we have something like that. Like that. This is the girl. She moves around. So what happens here is we have more or less you can possibly compress if you enter the world of Boolean logic for bits. Pig store in memory is the inverse of another pig. So, okay, you have like to figure out or elaborate an actual method for that. Okay, so we have, let me finish that. So you can see if we take the time and the changes of the changes are most often local, especially in this animation, since we have like one character, no background and so on. It's all one bit. So what currently we store like Quadtree, so we check like on this flat plane, this section nothing changes, but the probability that nothing changes for the next 8 frames of this 8x8 block is very high. So if we can store, like use 1 bit for this whole block in space-time, let's call it space-time here, on our 2D plus t space-time, that's even more beneficial. And that's what we did. we taking now 16 by 16 image. So the last row is always 0 to make it simpler. And then we take 16 images and compress that with 1 octree. And during the decompression, we decompress all the 16 images at once. And we have no decompression for that yet, and it's probably buggy because we had some bugs with the Quadtree as well, especially with storing or not storing the bits that are off screen in the last row. Let's talk about in a few years. I don't know how long. What is your coding history? I mean, I'm coding now for 30 years, so okay. Diff octree. So this is. Let me run the octree compression here. Yeah, 14% was what we are able to achieve with the octree compression. Decompressing it with Quadtree deflator is not working. Hey Johnny. Oh, what? Oh, you have COVID, yeah. Oh, I hope you get well soon. Man, 38.5, that's headache, isn't it? If you want to join my university, that's Technical University of Darmstadt, which is quite okay for computer science. But what I wasn't prepared that you have like to be a grown-up and actually take the courses on time and learn by yourself. There is not much. There is support. I mean, that changed a lot probably but there was not much support during the time that I was studying. There were like 600 students per like semester, or like 600 new students, which was overwhelming since there was like a boom in IT back then, around 2000, where I started to study. Flu? Not COVID, just flu. Yeah, pseudo COVID. Okay, yeah. So I'm jumping around in our theory. So what we can do today is we should finish. Oh, really? Miami? Okay. Oh, you have to pay big bucks, and if you study in, or are you going to community college? I don't know what the quality like. I don't understand why people in US. Maybe you can elaborate it a little bit. Why do people in the US go to like the big colleges like MIT or whatever to study there if you have like community colleges? What is the difference? Oh, wait, yeah, ESP32. We are probably the other person was maybe the Swiss, the guy with the Swiss accent. Fended Branca. Jay, hello. Okay, so isn't there a possibility for Americans just to come to Europe and study there, like abroad? I mean, in Germany, university is free. You pay only like some fees, like $200 or something, but that's more for the train ticket. You got like a free train ticket for the semester, and then everything is basically free. I don't know how it's for visitors, but like exchange students. But I'm wondering why people put up with like the ridiculous fees in US. That feels like a huge scam, because I mean you don't get probably you won't be like pampered here in the universities in Germany like you are in US. So the classes are huge, and you don't get a lot of attention in the beginning of the studies, like in the first semesters, but later when the groups are smaller and smaller. A huge decline, yeah. There's a lot of you can learn coding with some online courses quite easily, and there are some free online courses as well. If there isn't like a demand for an actual. Yeah, that's crazy. That's like okay. I don't want to be political, but it feels like it's a modern kind of slavery. If you have like, there is no way you can go like in those professions without getting a huge debt, which you're bound to your job for ages to get rid of to pay off your student loans. And then so you are basically dependent on the employer. And that feels a little bit of, it's cutting the freedom of basically developing what you actually want, or you're basically stuck with what you do for ages after university, and that feels bad. And I quite often see like TikToks or whatever of people that are complaining they're paying off for 10 years, and basically what they paid off was only the interest, and the debt is still 60K, or sometimes doctors have like 120K of debt, which you can basically buy a house for. Yeah. Yeah, there will be a difference, a change probably. Like you don't keep your profession for the whole life in future. Now with with AI, what's the point of learning to code? It codes. If you watch the first session of where we implemented the whole converter here, converting from MP4 to binary was completely done in first try by ChatGPT. I just did changes to make from the binary to convert it to an header file, which ChatGPT could also do. but it's perfectly capable of implementing like a tool with just one line request. So what do you need some basic coders for? $6,000 per year in China? Who can afford that in China? I thought the salaries are not that high there. That's crazy. Dutch, I didn't know that your family is with you there. And I didn't even know that you have a family. All right, so should we try to first try? Okay, what we can try to do is explore first, like do the decompression for the octree, and then try the Huffman codes for 4x4. Yeah. Subscription model. Yeah, quite expensive. Chinese girlfriend? Ah. How good is your Chinese? Are you talking like Mandarin or Cantonese or both, or what's the difference? It's like Shenzhen is this Cantonese? No, it's southern of China. Okay, I will do the decompression first. Pop. Let's hope it works. Difference octree. Decode. Oh, we are losing track here. Maybe I should put this in different files. New file. Mandara. That's strange. Encoder octree, and then we will just put everything in this file. Okay. And level 2. What does level 2 mean? I like fluent conversation. Converse. How do we how do you include JavaScript? Does it work like that? Encode quad. Octree. Okay. It assumes there is like the difference encode decode, and that's basically encode decode, block count, decode bit, which is really cool. We should use that more often. Frame X, Y. encode difference Quadtree. Now let's try if it's loading. Nope, it's not loading. Ah. Out of control costs? What does it mean? You mean like medical bills or whatever, or what? I don't know, how does it work with medical insurance when you're studying? Oh wow, okay, that's ridiculous. Ever thought of moving to another country? Yeah. Yes. Which one would you pick? I can't recommend coming to Germany. No. Next to bitluni, yeah. I like Germany. It's great. It gave me many opportunities, but it's too cold. Since I can go anywhere in Europe, I would rather move to Spain or something. It's probably Spain has less, like, say, infrastructure or whatever, but you have like more of the warm weather. Or if I was like a native English speaking person, if I would move from US and wasn't already a EU citizen, I would maybe pick New Zealand. Canada is a little bit cold. I like Canada, and I don't know how great like the health insurance is there. You have like a public health insurance, as far as I know. UK is no option. Australia is like everything wants to kill you in Australia. It's probably great as well, but I liked New Zealand the most because you have like all the possibilities there regarding the landscape. You have like warm climate and cold climate. You can basically pick whatever you like if you live there, but you're a little bit far away. South Germany, yeah, Freiburg, like Switzerland. Oh yeah, the Shippo can recommend Switzerland probably. If you can like get a visa or whatever, or like citizenship. You probably don't get any citizenships for Switzerland, but you can probably stay there forever. I don't know, the Shippo, how is it? How do you migrate to Switzerland? bitluni.con, New Zealand. Nobody will be there. It's too expensive to travel. Yeah, you can work there. It's in Schengen. Yeah, but how is it? Where are you insured in Poland, or are you insured like Social Security and stuff? Are you insured in Switzerland or in Poland? How is that? I guess like insured in Switzerland. Okay. And how does that work? Do you pay like, they have also like public insurance? So I'm wondering, yeah, how does that work? Oh, what does that mean? Very expensive. Give us some numbers. We need some figures. It's probably not USA expensive, but how's the cost of birth in like giving birth in the US is 10K. 300-400. Yeah, but that's not much for self-employed people or what. I mean, that's not much. I pay similar here for the whole insurance stuff, and that's half of it because I'm like an artist. So basically, for all foreigners. I don't think that's really expensive compared to Germany, actually. So you, my girlfriend pays like $1,000 or something. That's true. Germany is easy to have a con. What? 25 degrees? Yeah, that's cool. Yeah, but China is like, it's so restrictive. I'm not sure. I know people that live there, but I'm not sure. I never been there, so I have no opinion, no real opinion. How is that? As also with the political situation. During COVID, it was probably not fun living in China. Oh, that's cool. Yeah, that's easy. So certainly, Atom, you should inform yourself about Switzerland if you can move there. I would recommend. It's like a great achievement living there, and you have probably it's. I don't think you can get its citizenship, but if so, you are welcome everywhere. But with US citizenship as well. You can travel now visa free. Swiss spot, okay. Okay, how include JS file? Script, yeah, that was script source, not link source. Link was CSS. Script source, yeah. I will wait until after World War III and between Russia and EU. I guess there won't be any war between Russia and EU. Russia doesn't have the resources anymore. So basically they, I guess they're probably down 50% of all their resources. They're already down just with Ukraine alone. And that's like, we have like this proxy war right now with, I mean, US is sending a lot of weaponry there, and EU as well, and Australia as well, and UK especially. So Russia worn off very much of their resources, especially like people and tanks and air force or whatever, jets, helicopters, everything down. They would need to recoup a lot of time, so the only option would be nukes. But if nukes, then you are not safe anywhere. You're not safe in EU, especially not in US, since US is doing most of the support, military support for Ukraine. You are probably less safe in US than in Europe. Yeah, Europe is quite dense. Yeah. New Zealand. I recommend going to New Zealand. Probably have less fallout there. Cook Islands. No, Cook Islands is not a good option. Cook Islands. Yeah, if we have like World War III with nukes, you can it will increase the global warming even more, the climate change, because then you have like this clouds everywhere, and the temperature will increase, and you're not safe on any of the islands like the Cook Islands and whatever. They will just drown. So, but New Zealand, they have like also quite high mountains, so that's probably staying there, and it's so far off. Hawaii is. Oh, I mean, New Zealand is also volcanically active, but Hawaii is more active than New Zealand, I guess. So Hawaii would be, but Honolulu is probably on the list of the Russians. Their home bank, yeah. Switzerland, yeah. But you will Switzerland will die of like of the what I think would have ended. I mean, they had nukes. If you think about it, like U.S. had nukes, and that ended World War II basically, because Japan was still in World War mode. That's what ended it there. So depending on if you say like hydrogen bombs, then probably there will be we would live like in a Fallout scenario, like in the games, and but with only like nukes with 15 kilotons or whatever, there won't be much change. Hiroshima and Nagasaki are now still livable cities, so I guess it would same in the same disaster, maybe quicker than what happened during World War, because like Germany was also bombed flat with all the bombs. Yeah, not in a good way, I guess. But I'm wondering if like that's like a hard reset, and a hard reset can be okay sometimes. So you wouldn't know if it could be that after like World War II, which would end with nuking like all the big cities, um, the result could be that now 70 years later we would be more advanced, because there would be no cold war. The rich are already prepared. Yeah. I don't know about that. Don't Look Up is a good movie. Check that out. The rich are prepared. Don't Look Up. Middle East conflict? Really? Hmm. I don't know. Egypt has like nukes, I guess. No, it's yeah. If there's like a war, yeah, I don't know how that's. I don't think it was the Middle East, like the situation there, like with what we have with Gaza right now. The situation is uh, less bad than it was before, because now it's like being resolved, like the pressure, and which is not a good thing, but you don't see like nobody wants to be really in a big conflict there. It seems like nobody else is involved. Like before that, you had USA involved or whatever, and now nobody is interested in that because it's there's the destruction with Ukraine, and it seems like a good thing with Ukraine war is there, that we have the proof that there is no intention of using nukes by Russia right now. So and that's in some way a relief to be sure that the stupidity isn't like that bad. It's still there, like it's bad, but it's not dire. I hope I can see a hard reset in the world during my lifetime. Yeah, please, let's wait until I have like a house in New Zealand, and I will go there, or Antarctica or Greenland. I guess we will maybe live until Greenland is ice free, and that will be a new good place to settle. And also Antarctica. So Greenland, Antarctica, maybe Argentina. Okay, let's concentrate. Enough politics. Let's concentrate on octree, which is octree decompression. Complaints about cold in Germany. Yeah, but it won't be cold in 100 years. I hope that the advances in medicine will help me to survive like more than 100 years. So, but the climate change will make Antarctica basically melt some ice off there, and it won't be cold there. And by that time, at some point, like Greenland and Antarctica will be nice places to live. And yeah, everything else will be wastelands. Oh yeah, that's good. Or the advances in medicine will be cancelled by advances in shareholder profit margins. Greenland, I don't know. There are no. Iceland is full of volcanoes. Greenland, there's only like a huge. Yeah. Greenland is, I don't know of any volcanoes on Greenland. It's just like a thick ice on top of like old. At some time it was like a green land, but now it's, since I think the last ice age, there's still like this thick ice on top of that, but I don't know of any volcanoes there. I think Iceland, what you mean is Iceland, which is basically on the corners of the tectonical plates. But I'm not sure. It was never green. That was marketing too. There are no volcanoes who would want to be eaten by a polar bear. Here in Greenland, there won't be polar bears. They will die. They die out. They are living they are living on the ice shelves, which will basically. Yeah, Iceland. If you take the name, yeah. Bipolar bears. That's cool. Okay, let's decode oct. Political rants. That's what we do here. Encode, decode, diff. And we will decode here. Decode diff oct. So what we do is decode, decoded, migrating deadly animals. Yeah. It's strange how different Australia and New Zealand are. They're so close to each other, but still it's like New Zealand is like the most friendly place you can be, you can live in. There are basically no animals that could harm you. And Australia is the most deadly continent, it seems. Now, I mean, like, there are now rodents and so on, which basically people brought to New Zealand. But other than that, there were only birds before that. Birds and axolotls, lizards and birds. They're about as close as Europe and Africa. Really? Yeah, that's only a few hundred kilometers. That's only a few hundred kilometers, is it? Really? Nah. Yeah, I don't know. Yeah, probably. You would be anxious of a snake biting your ass. New Zealand, here we go. What's... Oh, wait, that's 800 kilometers, Tasman Sea. Yeah. Yeah, that's... Okay, that's 1000 kilometers roundabout. If you... Tasmania is a little bit closer, but... Upside downing. Yeah, 1000 kilometers is not that far. You can go by car underwater for one day and then you're there. Yeah, that's 1000 kilometers. So, yeah, I've been there for 5 weeks and it was really cool. This is really warm and there are penguins here. So, you have like really different things. And you have like, where is that? Tongariro. Volcanoes and Alps. Mount Cook is somewhere here. Is this Mount Cook? Where's the Mount Cook? Yeah, that Mount Cook. Which is a high mountain like this. These are like the Alps. Volcanoes, everything is there. Everything you want. And jungle is up here. Here you got some jungle as well. The dolphins. No, where was it? Akaroa? Was it Akaroa? Oh wait, this is the southern. Oh, okay. Yeah, I was here. There are dolphins. Yeah, amphibious cars. All right, let's do the decompression. Encoder, decode, diff, oct. Now we need to see. I never ate one. Offset return. Oh yeah, the Lotus Elise James Bond edition. No, Lotus, which one? Yeah. Penguins, I never ate penguins as well. Pop, pop, pop. Yeah, we need to decode it. Z. What is the... Oh, we need to change the encoder as well to convert it. We are like this conversion of the encoder. Ah, no. This is the decoder. Oh wow, we will get a lot of snow here. 15 centimeters and 20 centimeters. What? Oh damn. That will be crazy. We'll have a lot of snowfall here. Local cuisine. Yeah, I hope we get... Ah, let me check that. Now I'm worried. I have no way of getting the snow off the roof. There will be tons of snow on the roof then, if it doesn't melt off at some point. Here, let me check. When is this supposed to be? Doesn't load. Here, doxing myself. Come on. Don't play, stop. We had, but if you look at this region, I might live or not live somewhere close by. If I zoom out. Okay, so this is today. Wait. Oh, okay. Look at that. What is happening here? Yikes. Deshipo, what are you sending here? No, that's more from France. What the F? And this is now like really stretched. That will last forever. That's more like tomorrow during the day. Shit. A lot of snowfall. What does that mean? Is there a legend somewhere? Yeah. Pink approved. And now let's see. Yeah. This is probably rain and this is probably snow and a lot of... Oh, you're on Tenerife? Yeah, you're standing here. Tenerife is here. No, wait. Tenerife is here. What? Yeah, you sent this over. Look at that. I can see. What are you doing on Tenerife? Are you on vacation or are you working remotely? Home office? How much snow is that? Is this a lot? Where's the legend? Here. Schneefall. Viel. But this, I think this is the one. Yeah, we see a lot of snowfall. Oh, okay. Yeah, what's with your health, the sheepo? I'm worried about you always. Oh, look at that. If you look at this region, we have like 0 here, so it might melt down. But if it freezes all the time, that might mean that it will just freeze solid and will never come down. That's terrible. So that's 0, 0. Okay, we have snowfall, but it melts. Still 0. And then, yeah, no. Oh, that's only for tomorrow. Oh, but we have freezing temperatures. Yeah, fuck. 0. 0 is the best we can get here. That's at 14 o'clock. Shit, -10 again. Oh no, please give me a break. Okay, Friday. That's like a forecast. And then it's warm again for a little bit. Warm is -1. But -1 is not enough. We need like 4 degrees. That would be the best. Oh well. Yeah, but we don't have as much wood to burn in our oven. There is no solar stuff here. Electric heating. Yeah, weird. I will just open the hatch to the roof and warm everything up there. It will melt at 0 degrees. Everything will melt on top of the roof and the snow will come down. Last time we had that, it was like the snow was stuck on the roof for like 2 weeks or whatever. And it piled up, even though the roof is quite steep, but it was -10. And, well, 50% of time of a flood into your house now. No, there is no flooding in my house. I did a great job with the trench. Our basement is now dry. Why all the basements in center and north of Germany were drowning due to the rains and snow melt. We got some relief in the basement. There is no mold nor anything. That's really cool. The one of the rooms is still like having this dehumidifier, which is running like all the time. But the other one, which is close to the trench, even like we had like the floor, or there was like a water bubble underneath the floor, so it was like bent up, and everything settled now. So everything is gone, like the water underneath, and it seems like it was basically the relief already that the house needed. And I hope like during next year I will be able to do the other sides of the house as well, and then it might be even a livable space down there. So if I can put like set up my lab without a dehumidifier and some machinery and sensitive electronics there. Okay, I will take a short break, a wee break. Can I put activate an ad? Here, you get an ad. Ha! Why I go wee. Solar radiation. I should paint my roof black. There was no ad. Why though? Huh? Insert ad. I pressed the button. Yeah, so I don't earn the 20 cents or 10 cents of you watching now. Am I able on Twitch to insert an ad? Let me try that. I will annoy my 5 viewers there. How do I? How can I? Oh, nice. Here, 30 seconds on Twitch now. So now that Twitch viewers, now we can talk smack about the Twitch viewers. How do you think? What do you think about Twitch viewers? We have 15 seconds left. They're watching an ad. Oh no, 5 seconds. Yeah, so what I wanted to say, Twitch viewers are really, really cool. I love them. What? Okay, in 7 minutes I could set another break on Twitch. That's crazy. Every 7 minutes, half a minute of ads. This is crazy. Hey, Killian. Oh, Ants is also here. I didn't even check who joined. Chat comment to spawn. Yeah, a war between YouTube viewers and Twitch viewers. The Twitch viewers can activate YouTube ads, and the YouTube viewers can activate Twitch ads. All right, how does the compression work? Oh yeah. Z is zeros. Z times, oh wow, Z times X res times Y res plus Z res is because we have. Oh wait, no. We always decode all frames there. Interesting. It's always a multiple. We don't know how many frames it is. It's a multiple of. Yeah, there is no limit in that here, I guess. So we don't need that. It's always 16 by 16, 1 and Y, Z. And we have we don't need that. Actually, we don't need to store to do those checks here. We don't need those checks. We don't need no education. Z SH, and this will be Z plus SH. This is the octree decoder, which won't work. Believe me, I know what I'm talking about. Carefully, hello. What? What text? Yeah, this is the decoding, and we have 16 by 16 because we decode always 16 frames at a time. And we start with 0 and we push decoded. This will be decoded frames undiff, and we have, that's all, I guess. But the decoder and encoder and decoder won't work. Yeah. YouTube chat is terrible. I don't know how to fix that. Okay, here we go. Okay, the decompression, the octree decompression. Okay. Oh yeah, we have the wrong order. We need to change the order, which makes the encoding really, really slow. But we did that. We did that already with the Quadtree here, because we need to store the bit first. Unless we rewrite it. So the check and the storage will be different. So like Quadtree. Yeah, here is now Quadtree diff by diff quad, and we return, nope, this is decode encoded. Yeah, so this is what we need. We need to return arrays and then push the decoded arrays here. This is what we need to do here to get the right order in the Quadtrees. So this will be basically that. Return, then we have push top 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 top. Oh, there's no way to cast switch? Isn't there like an app or anything? Wait a second, how did I do that? Return R. Oh yeah, that's the return value. Shoot. Yeah, that's not encoded push. We let R, so bits return. Yeah, that's R1, R, R, and return 0. Oh, that's the JavaScript, but so there is like this. This is an array. I'm returning an array with just the bit, which is 1 or 0. It's untyped. That's probably why it's slow. And then I'm collecting all the bits of recursively. What happens is it builds up the order of the octree sequentially with since. So the issue before was we going depth first and then storing like the last bit first, but we need to decide beforehand if we go all the depth. So we need to store this one first before we store all the bits of the trees below that. That's why we construct like this subtree here with the 1 and attach all the subtrees afterwards to the and return that whole chain of bits. And this is basically the 0 subtree, which compresses all the way. And now we need to encode it, push bit, basically that. So this ... is the operator that basically flattens the array. So it passes the contents of the array as attributes. So we can use the push basically to append. That's just a fancy method of using an append of this array to this array. And I hope it still works. Nah, didn't work. What is that? Yikes. What is that? 51 bytes. Yeah, we lost something here. Return. That's not good. R push const bit. Let me check. Yeah, and our conversion wasn't great. Bits offset return. Oh yeah. Return 0. That might be one issue. No, still not. Let me check the Quadtree. Wait. Yeah. Yeah, a bit lossy, yeah. I was missing this part as well. It's interesting. Yeah, but it flattened that, so that worked by coincidence. Ah, yeah, that's missing. 0. We need to check if any of the first bits which indicate this was missing. Oh wait, bit 0. This is also a bug. Nah. Nah. Still nah. Something's broken still. Now it does something. It does something. How did we change the converter? Did we store? Generative art. Wires at We have still that here in place. Encode, return 0. I should remove the conditions because we had yesterday we had some issues with the conditions as well. So I need to remove those from the compression and... Oh wait, that's the wrong. That's the Quadtree. Shoot. Ah. Might be just something broken in the way how I pass the parameters as well. So we need to check that. We have XYZ, bits offset XYZ. Okay, this is the compression. Z. Return 0. That's all right, but then the decode also needs... This is the extra condition. 45 kilobytes. That's not 14% anymore. And the decode doesn't work as well. What did we change? Shoot. Imagine our compression is broken. But I don't see unless I will fix it, unless I will see a change. Okay, let me check that. Array. Now that's the decompression. So times frame plus 16. Zeros. 16, otherwise frame count. That's all right. And we have bit 0, 16 bits. Offset IS. Bits offset zeros. Offset zeros. We have offset XRES. Okay, that's the pointer. Then it returns 0. Imagine that our compression was broken somehow. It's 8 bits. Push, return R. I don't see a bug there. Oh no! Why did it change so much? Let me check what the result is. 360, what is that? It does something. Oh wait, I don't have a pointer for... I'm wondering how does that... I need a pointer. What is the offset here? The decoder. Yeah, the offset bits. Is the 80? Oh no! Oh no! We can reduce the whole thing with the Quadtree already to 31 kilobytes roundabout, which is 18% of the original size. That's sure, because we have the decompression. Now we are at the octree, which somehow changed due to us somehow like changing that to reverse the bit order and removing like this extra conditions here. It seems we are having some extra bits with the octree, so it seems octree isn't for 14%. Now we are at 50%, which is not that great. I need to remove all the extra conditions and only save like let us. I could remove the condition for Z here to have like 16 by 16, but I think there is something broken. That looks odd. That we are now at 22% with the octree, and the decompression doesn't work, and I don't know the reason why. Diff octree bits 16 by 16 by 15 filled 0 decoded push length. That looks reasonable. Then we have X, Y. No, you need to have the bits, the bit order that way, because you need to know if you go further down the tree. You don't store all the tree. If it's 0, you don't store the subtree. And going depth first, like our original encoder was doing, would store like the lowest bits first, and you wouldn't know if this is like what level it is. So we really need like the top level first. And we could do it a different way, but like testing first, but not storing, like not doing the subtree, just testing testing first and then storing. Because then if you test it, you can store the bit and then continue storing all the subtrees same way, which will traverse the tree multiple times. Like we have a quadratic effort to store the tree if we don't do it like that. Okay, but I'm confused now why this decompression doesn't work. fx, let me check. If not bits, the subtree, then we have return. Otherwise, at this level, and z times 16, that's all right. Otherwise, we have decompress that. Strange. Should we try without difference so we can see if what the matter is here? Let's try without difference. Oh, that looks like broken order. You see that? It looks like a copy paste. It seems like there is a copy paste error or something. The tree is stored in the wrong order. Yeah, that looks suspicious. But also, yeah, no, this is not right. That's Chrome. Yeah, okay. So, let's check. We should have like one still frame that we can test or something. I guess we store some extra stuff here. I'm wondering, return 0. That's all right. Return offset plus p. Can improve that. HS. Oh, live share. Wait, how do I do that? Here. That's live share. Hey, secret engineer. I have my own plus Huffman. Huffman on top, what saves a little bit, but we have like on, I would need like to re-explain everything. So Huffman codes help a little bit with the lowest level of the Quadtree, but we are now trying the octree, which was better results than Quadtree, but it seems it might have been buggy. So I'm trying to reduce the steps here and the extra conditions and so on, boundary conditions, and we have some broken. Yeah, that the compression shows something is off. I'm wondering if we are storing too many the wrong stuff there. X-res, wait. Oh yeah, we need, no, this was the condition, the extra condition. We are not canceling that. Always expecting a bit. If not bits, offset return. Otherwise, if it's 1, then it's 1. Which also is alright. Yeah, that should be also, if we are using it already. Hey Green. Hey Sniff. I'm missing something. I'm not sure what. Should we clean the code? Like this is. That's all right. That I don't expect any errors in that copy paste code here. Yeah. C plus SH. No, there is no copy paste errors. Oh, that's the error. Oh man, really? Okay. Oh, such a stupid error, man. Give me a break. Ah, copy paste code. Okay, now let's do the diff. Okay. Here we go. Yes. Compress, but still it's no good because the compression is not 14% like expected. We are at 22%, and we have a better one already with the Quadtree. So what changed? It's we removed those conditions here. Let's see if that changes anything. 16? Where's 16? Oh, that's not the line. Wait a second. This is completely, yeah, broken. 4.2. What's wrong with those conditions? What is the success rating? Hey Kaspar, it's good. It's good. We have some. Yeah, since yesterday, nothing changed with the octree. It's still 18% compression rate. The Huffman code, we calculated, not implemented, another 6% of saving. 6% of saving on top, so we are down to maybe 15, 16% original size. Live share didn't work? What? It shows it's shared. Now with the extra conditions, something's broken here. The compression broke. Why did it break? Now I have to... Something's broken here. Why? What does the Quadtree have? Extras. Yeah, this is... Ah. Oh, Fentland's so loud. Okay, let me close the live share. Stop. Since this is running from yesterday. So let's do that. Here. Here a new link. Okay. It worked? Yeah, okay. So what did we break in the encoder here? Let's start, you know what? Let's start with if z plus hs, if z plus hs is z-res, but that's not what no, it's not new. We did this before. We did this before, my friend. You were probably... That was probably before your time. Let me check that. ZS. Here, era. You call it era. Okay, okay. Let me check if... No, it breaks. So zres is broken here, or what? Yeah. Okay, I'm sick of that. I'm sick of that. Okay, there will be always zeros, will be always 16. Because I'm not sure what's happening here. We have, is this all right? S bits offset. No, it's the total number. It's the number of frames in this block, because we're using here. You missed the thing. Since we're using octree now, we have space-time. This is like the girl that's moving through the space-time, and we are storing blocks of 16 by 16 by 16 and trying to compress those at a time. That's why we are taking chunks of 16 frames right now. And I'm just checking if I did everything right here. That's the offset. And we have zeros. Oh yeah, that was the offset missing. I mean the zeros here. That was terrible. Okay. That never worked. So the compression was broken before. We can't achieve 22%, but that's not good. Unless I can do Huffman coding. So Quadtree is better than octree. Bad. I should feel bad. If y plus hs yeah, I add the right y resolution here so we can store a little bit fewer, a little bit less bits. Wait, oh yeah, zeros. The decompression will append empty frames to a total of 16. Okay, that's still 22. And or yeah, but this will never happen. Did I enable edit? Someone's marking the 80. I hope you're not able to edit it. Trolls will be kicked. XRES and the compression here. That should never trigger, so I guess why did it not paste my tab? Huh? Okay, here. Okay, now we are this is fixed. Yeah. All right, 22%. Unless I'm doing some Huffman coding with the last level, it's worse than our Quadtree compression. That's disappointing. I thought we're at 14%. Damn. I mean that uh, gives us some relief on the decompression side, because otherwise I would need to store 16 frames at a time. Hey Jordi. Oh, the hangout time. Discord hangout time right now. Damn. I would need to end the stream here. I will do for a little bit longer. But we got the decompression. What I want to do is maybe clean up a little bit. Wait. Yeah. I add encoder Quadtree. Quadtree JS. And I will move the compression. We have run length, diff quad, basically, but decode diff quad, and I need to fix stuff there. And we will move back to Quadtree decoder here because that's more efficient. We seem have to find Quadtree. Div quad. Okay. We will. Okay, so Quadtree 18%. Yeah, that's what we get, peeps. There is no way around except for we have 2.2 kilobytes savings on top of that, so we are at 33 kilobytes if we use Huffman codes. If we want to use Huffman codes for 4x4 pixels, it might change everything, but then we need to figure out how to generate the dictionary, because we don't have so much memory to store all the codes. There are many codes that never appear. Like some constellations never appear. There are 0, 0, 0, 0, 0. That's cool. That's really strange, but really cool. I'm wondering how many different... Okay, let me recap. Oh, let me fix first. So let's... Stats for all... Oh, you mean each different level, what codes are like used how often? Interesting would be... Oh, we are only calculating the Huffman codes for the last level. If we could use Huffman codes for all subtrees, you mean like, let me draw it. Yeah, that could be. So we have now like we are storing. This is now Huffman, and we expand this to the next level. And we want to use Huffman for each level. Interesting. We can do that. We can calculate the probabilities. Deep rabbit hole. We are already in this deep rabbit hole. You missed the beginning of the stream. Just watch the beginning of the stream if you want to see. Hey Regis. Slow frame rate. That's way too slow. The frame rate. No, that's 30 frames per second. What? Is there something broken? No, I thought I made the playback 30 frames per second. Or I'm expecting... I don't know. What is the original? No. I'm capturing it at 30 frames and encoding it in 30 frames. I used that 0, for the next pattern more rapid. To mate for the encoder. I don't understand that Z80. You need to use shorter sentences, otherwise my brain would be able to process it. What? With slow frame rate? No, the decompression is quite quick. If you look at it's really fast if you consider the Quadtree decompression. Basically starts with an empty frame and it recursively just... No, this is octree. Wait. Why did I change anything here? What did I change here? No! I hope I didn't change anything crucial. The Quadtree decompression is quite simple. It's a lot of... It looks like a lot of code. Multi-level, you mean like Huffman codes plus... It's just a lookup table. So what Huffman codes would do here is if we use like the Huffman codes for the last level, would basically add like if s equals 2, then take like the consecutive bits and consecutive bits and use that as a reverse index. Oh, I could do a reverse index lookup table, because if I ignore the bits after that could work. Like really fast decoding. Huffman decoding, we can make it fast because we are using up to 6 bits. Let me check, let me show that. We have here. These are the best Huffman codes I was able to determine so far for the last 4 square of 4 pixels. And they have at most 6 bits. So you can make a lookup table for 64 values and just ignore the last bits here, or repeat basically this value in the lookup table will be entered in at this point 0 and 1. So it's basically in the lookup table in 2 places. So the lookup for the Huffman codes will be just one array access, and the index will be increased by another value that's stored here. But yeah, it will be 128 bytes that we need for quick Huffman lookup here. That's now the interesting part is people who missed it, I already calculated these are the probabilities or the counts for the pixel combinations, and we are always storing only the difference, and this is basically like one pixel change in a 2x2 is like the most common, except for like no change at all. And then we have 2 pixel and then 3 pixel, and 4 pixel change is even more common than 3 pixel change, since we have sometimes like a lot changing here at once, like the whole frame is flipping from white to black and vice versa. So these are the Huffman codes. And now what the Shipu wants to know is how often do we have like the counts for all levels of the quadtree, since we are only like looking at the lowest level, and do we have like a different counts for the other levels, and we can implement that. So let me check that. This is block count 4x4. We can do decode we can try and do that. Or do we want stats during the encoding? Stats. We just expect an empty array and then stats push counts. So yeah, that's bigger than that's what we can achieve with Huffman. The XOR delta, I uploaded also a diff bin on Discord, so you can use that. That's basically using the same. You can just try to compress that. That will be way easier. Huffman layers should speed things up. Not really, because you have still a variable. It's not way slower or anything, but it's not faster either. It's a little bit like a few cycles or whatever, because we have some lookups. Okay, let me check. What we want to do here is starts, if starts. Oh wait, that's interesting. Let's expect the stats here. If stats, then the images are compressed my quadtree compression. Watch the beginning of the stream. You can rewind to the beginning of the stream. is used to make the tree and the rest of the numbers something pre-calculated. Don't get it. And the rest of the numbers something pre-calculated. Huh? You used 4 bits of the output stream to store 4 bits to make the yeah. Yeah, you probably. I explained it a few times, and I can't do another round. But if you know Quadtree, that's what we do with the image, and we store only parts of the subtree where at least 1 pixel changed. That's what we are doing right now, and the 0 basically means nothing changed in that part of the image, and you can just recursively do it for the whole image. Starts. Okay, so starts, no, const. Yes, it is. I am able to do my passion projects now. Index equals that's shift. Let's not shift it. Okay, shift 1. Shift 2. Shift index, and then we need stats index plus. Okay, in this project, I have like this animation bad apple, and it's 1 bit, 16 by 15, and I try to fit the whole animation of 5,000 frames in 14 kilobytes of flash. So a run length encoding was way worse. We implemented run length encoding. Is terrible. Then Huffman, we calculated for the last level that we can do 2 more kilobytes of savings, which is not much. So now we are calculating how much Huffman codes for the whole levels, what probabilities we will get there. So this is the stats, and now the compression will store the stats. Zip it. Yeah. We try to zip it, and we get also like around 30 kilobytes. The same what I get with my Quadtree. So it seems like it's the entropy. Stats. Oh. Let me check. Stats. Okay, if oh, evil. Yeah. Okay, now let's do the following. No, we should have the whole starts for oh no, wait. Encode, decode, starts, frames encoded. Wait, frames encoded, that needs the starts. Starts encode, starts, and we will do it here. Starts, encode, starts, and we just do starts here. I don't know if what we count here actually, if we count anything. Okay, so these are the levels except for like 0 is never stored as a 0 because that's cut, that's not stored. I don't know how often it's we need to count this as 0 as well. Quadtree. So here return 0 else. Is this quitting? Yeah. Okay, here. If starts 0 plus plus. So we will also calculate increase it here 487,000 times the 0. The others are quite evenly distributed. We have 10K. That's what we are used to. One thing is changing, like 1 bit is changing. Then we have 3K. That's similar to the lowest level. No, that's very specific. That's like only 1 bit images and animation as well. So and it's optimized for this animation because if we had like, I don't know, a background that's changing, it won't work like that anymore. I mean, you can use it for different bit planes, maybe. Not sure. The compression will be bad for the last bit plane. You can throw it away maybe. So Huffman codes still similar to what we had before. So if we would use Huffman codes for, what's the saving? 3 kilobytes for all the levels. Okay, so Deshipu, there's your answer. We could save like 1 kilobyte more if we use Huffman codes on all levels. We can save like 3 kilobytes. But I'm not sure if it's storing like the last level. I guess so. Yes. Yes, that's all the levels. 3.3 kilobytes is the most savings we can do here. And I will take another break. Here you go. Break. Yeah, I don't know. It doesn't work really. Probably don't have enough. Whatever. Okay. Yeah, I don't know if it's worth doing like for 3.3 kilobytes. That's like 10% more. 10% will be down to like 16.2% of original size. What someone could try is using GIF compression for the 1-bit thing, but I am not able to convert to 1-bit GIF here. I would be wondering if you can do that, but the decompression of GIF is quite memory consuming, so I won't be able to do it on this small microcontroller. Maybe, no, wait, I could be. Interesting. It's only 1 bit. Alrighty, so here, these are the probabilities or frequencies of, we need to maybe sort them, of 4x4 pixels, which would be like a completely different encoder without a quadtree. We can check if there is a way to make this like the Huffman codes, because we don't want like a 65 kilobyte library to decode the Huffman codes. But you can see the frequencies. There are even like many constellations of 4x4 pixels that never happen. So they will never appear. Most of the times we can calculate. Let's count the counts and see what happens, what we get. Okay. Where are we? Div bisect. Let me do that. Coder. That's not KD tree, that's binary tree. I don't know anything about arithmetic coding either, so you would need to provide me with the actual stuff there. Binary tree, we tried that, didn't work as well. So this is binary tree. We can skip that, and we had also run length encoding, which the decoder didn't work. We had like inverted lines. That was an issue with that run length encoding, but I will also add this to another encoder, RLE.js. We don't need that. Hey, what are you doing? You can't change the view. Here we go. Block count, encode, decode. These are the Huffman things. Oh, we can check if we're able. No, but I don't think we're able to save more than with this Huffman code. Download binary, block count. Here, block count. That's the savings. Counts savings by Ollie. That's cool. We see people appearing. So we calculate 4x4 blocks, and now we can do the following. Const counts 4x4 equal, and now what I want to do is calculate for Letty. How do I sort this? Hey, Rote. Rote, bad news. Octree compression is not better than Quadtree. So the lowest we can go, even with Huffman codes right now, is down to 32 kilobytes for the whole animation. We wanted to sort the counts. How do we sort an array? Array prototypes, array sort. Okay, yeah, let's do. Counts frames. Sort. Or undefined, okay. Sort, I hope it lets us keeping. What I want to see. Wait. Wait, sort. Or undefined, okay. So we can sort it without, so we just see the frequencies of reverse. Different, yeah, but then you would need to store the Huffman tables, and the Huffman tables take a lot of space. If you consider that we are only using 5 or 6 bytes per frame right now with this compression, it's really, yeah. And especially what we expect is always that there are only like at most one pixel changing in a 2x2 section, because the contour changes with this frame rate, and we are only storing the difference, so the delta, which is an XOR basically between the frames. Free? What? Are they kidding or what? This is silly. This is silly. You know what? Okay, let's do that. Const codes, and we have an array, and then we do the length, and we do the following: codes push, and we create an object codes we push I, which will be bits is I, and then we have count, which will be counts for, here we go, push, and now we will sort codes, and the algorithm will be, how does that work? Need an example with this lambda compare function. How do you write a compare function in lambda? Come on. Yeah, AB. AB. That's basically A count a B count if I don't know. We try and then reverse if it's the different one. Oh wait, we displaying, no. Codes. Zero. Yeah, that's what I thought. Okay, here are the counts, peeps. Oh, maybe we should, how do we convert JS to string 2? So it's easier for you to see that. I to string to base 2. Okay, so here we go. So what we get is, that's always like the most common things is when 1 bit is, like 1 bit is the most common thing. That's happening. No bit is set and 1 bit is set is the next common, which will be probably, how often is that happening? That should be 16 times. We count. Yeah, 16 times. We have 16 times. It's only 1 bit. Then we have the 2-bit constellations, which are ending here. Wait, no. There are even 3-bit, but does it really matter? Look at that. They are really close by. It's all around here. Do we have? Oh yeah, we have plenty of stuff that's only like one time occurrence. Look at that. So there is plenty of stuff that happens only once, and we have, yeah, this stuff happens like 20 times, whatever. That can be almost ignored. imagine we can save, like, store this, at least this here, this one in 0 bits, this one in like in that's 16, let's say in 4 bits, 5 bits, no, 5 bits, and the rest basically uncompressed. Uncompressed plus 1 bit or 2 bits or whatever. That could be the Huffman codes. How do I build a Huffman tree for that? Now I need something like a Huffman tree that's generative. Because we can't store the tree here. But what we can do is, we know that here. So let's sketch it. We have a function, or let's sketch a function, okay? Let's sketch a function, draw frame codes, let's do that. Encode Huffman 4x4. That means pixels compressed over USB. Yeah. Yeah, but that's not what we are curious. We want to find out what we can achieve, and it's quite simple already with the Quadtree. And if we can explore Huffman a little bit, that's all right. I hope I wrote Huffman correctly. So pixels is basically like a switch case in that manner. So we can say if pixels, no pixel at all, that's like the best level. We return that. Hustle, Hoffman. Yeah, with the love of hassle. Then we need to count bits. And for let I is shorter than 16, we have 16, I plus plus. We get an index because we need to check, okay, if I equals pixels, we return here, return only 1 pixel is set, okay? And we return basically our Huffman code, which will be 1, and then we need to store at least 16 plus something else. So we need to store 5 bits, which will be basically like that plus I encoded, like decoded in I shift by 3 and 1, or yeah, I shift by 2 and 1, I shift by 1 and 1, and I and 1. Is it that? No, different order. We store lowest bit first. No, wait. Yes. This could just work. We can try to, we can see, but this is already shitty because we don't save a lot. If we consider the best case scenario here, okay, so in that case, okay, this is only one bit. One bit. In this scenario, we have already 1, 2, and then 4, that's 6 bits. And then anything else, we can, this is like a lazy Huffman code. And then we can store like 1, 1, and the whole code. So we have basically four here, uncompressed, pressed, uncompressed will be basically for blah blah blah, uncompressed, let bits equals, and we store the 1 and the 1 that we need here, and then we will basically add all the bits here, which will be bits push, whoopala, push, okay, have a good one. I'm hungry too, I will cook soon. Pixels, shift right I and 1, and that's basically it. That's basically it. So in the decoding of that, encode Huffman 4x4, what I'm cooking noodles later. The code Huffman will be similar, which is easy. Decode Huffman 4x4, and it will be bits, and we return pixels. Basically return pixels, and the pixels will be const pixels as new array 16 fill 0 return pixels, and if bits starts with 0, then we can ignore it. So if bits and 1, because 0 is basically the else case, that's else all 0. If bits and 1, if bits oh, the decompression is here. We can try do offset if we want to like decode everything. We don't know how long the code is, so let's start with the offset. Ah shit, no, that's not good. How do we decode this? should we just pop or shift? Shift. Is that the right one? Shift. First element. Okay, yeah, that's what we want. Okay, we remove the first element, which decides blah blah blah, and then we do the same here. So if it's a shift, then we have uncompressed, compressed. So we destroy the array, but it's easier for us to implement here. Pixels uncompressed, else we get the following, which is basically const I, which will be shift or one. Okay, that will be that. That's the index, and then that's the index of the bit that's set in this condition. So that will be basically pixels I equals 1, and that's all. Return pixels, and uncompressed will basically get 4 let I equals 0, and then we have I is shorter than 16, I plus plus, and we have basically pixels I equals bits shift. That's the decompression of the Huffman, the basic Huffman, which only considers like the most common codes. Let me check. That will be the most common, and the other ones are basically +2. I don't know. Let's see how that compresses. We can try doing that. Block count 4x4. We can use that to encode code Huffman. And we use, that's the stats, we don't need that. Okay, that's all the frames. Oh, we need the diff. Const diff first. It will be diff, or let's take it bits. Diff 16 by 15 frames. Then we have encode. That will be, oh, and we have here const, and this will be encoded. and we will store, we do that 4 by 4. So what we take here, yeah, that's the blocks. What we do is we do the bits. Now Huffman, encode Huffman 4 by 4. That's the pixels is I. And we get the result, which we just encoded push ... We don't have the decoder yet, but we will be able to compress. Nice. Any patents? No, I don't have any. I'm too stupid for that. I should have done that, but I don't have the money. I want like I would like to have like a patent lawyer and just send him stuff over to handle that and just pay the $1,000 or how much it costs to file a patent. It would be nice. I would have some patents already if I had like the spare money for doing that. One patent then that I would file fondue cam. Yeah. It's trademark. All right. Encode, decode. Now we can do console log let's say const Hof, Hasselhoff, code Huffman, and what we have. Yeah. Frames and code Huffman frames, and then we have half and puff, yeah. Patent spending for half and puff. Half length divided by 8. Okay, dudes and dudettes here. What's what up? Huh? What's wrong? Iterable. Okay, so there is one missing. Return, decode. Wait. There is just one tree missing. Yeah, return bits. That's missing here. Yeah. Here we go. Look at that. What? Why though? Shit. That's not good. Yeah, no, here. But how do I use, like, I mean, I can do a patent and then I just send it to the patent amt. I need to like spend time to figure that out. Yeah, that's not great. Uncompressed, we're only able with this Huffman codes, we're only able to save that seems to be wrong. Not great. We are not able like to do any savings on wait. Oh, wait. We used the wrong ones. Encode. Wait. We need to use bits, not frames. Here. This is wrong. We need to do that. Peeps, I found an error. We were storing the, not the difference. This will now, oh yeah, not bad. But Quadtree still performs still better than that. We could try to improve here in that case, like these cases which happen like 100 times. We could try to save on that. But that's like, yeah, 3 bits, 3 bits changing, 2 or 3 bits changing. That's harder to calculate. We can do all the 2-bit constellations. Two-bit constellations could be stored in. Yeah, that's already like run length encoding. Since we have like changing bits, like let's say changing bits, we can store like 4 bits for the position of the first one and then another 4 bits for the second one. But there is still like overlapping, so we waste a little bit of stuff. But that would be storable in 8 bits plus. But I imagine, yeah, that doesn't help a lot. We don't get in this ballpark here. So Huffman does okay. It's easy to calculate. 43 kilobytes. It's quite simple Huffman compression. What we could do here is like doing just storing. Wait, this is the code. Yeah, just encoding also 2 pixels. If we get like the sum of the count of bits that are set, and then just storing the index of each of the bits. I don't know if we can. Nah, there's not much improvement. Yeah, we could use that, but then we will get an extra bit for the uncompressed stuff. Since we can decide, so oh yeah, We can do like 0 here or whatever. Wait, pixels. Yeah, here. 0, 1, 0. And then the 2 indices, which will be 11, and uncompressed is 16. So we save not a lot. How many times do we store that? Constellations of 2 is 16 by 16, 256 times. We can calculate that. The maximum estimated saving would be, yeah, that's 26 times 256. Let me calculate. Let's say we have 2 bits around 20 times. That's like a ballpark estimation, 20 times. And then we have 256 constellations of 2 bits set in the 16-bit. Yeah. Wait, no. No, yes, it's 256. That's like times 156 constellations divided by 8. Yeah, 600 bytes of savings if we do another level, but then we waste on the uncompressed, which will be a lot more. So I doubt we just getting closer to the actual theoretical limit. Okay, peeps, it's 8 o'clock. I need to cook and watch a movie. Yeah, sorry, no hangout today. I'm so sorry. I maybe join the hangout while I'm cooking, so that would be nice. On Discord there will be hangout, probably running right now. Thank you for watching. Tomorrow at 7 o'clock in the evening, or maybe earlier. But at least I will stream at 7 o'clock. That will happen. Not earlier. I will go to the city tomorrow. No, cleaning. Something like that. So at 7 o'clock Central European winter time. Yeah. And tomorrow we will do sound, okay? There is a speaker. We need the audio. We will store as many frames as possible of the animation implemented on C and convert the sound as well. See you tomorrow. Bye bye everyone. Oh wait! Before we go, raiding time. I forgot how to do that. I don't know how to do that on Twitch. Let's raid someone. How do we raid people? Here. Raidception. Clip erstellen, blah blah blah. Channel, raid a channel. Here. Teaser, you deserve that. Raid begin. Yeah. Yeah, Teaser is so nice. He's subbed and he rated me as... Here we go. Let's raid. How do I see now? How do I see out the raid? Do I go to Twitch TV and then see my raid there? I have no clue how that works. Ah! Yeah, two people. So, check out Tisa. It's German, but he lives in Sweden. He does ESP stuff as well. Here we go. Oh no, then go to teaser CC. Teaser CC, that's... Here we go. Okay. If anyone wants to be rated, then next time we will do that as well tomorrow. See you everyone. I will end the stream now. Bye bye. Ah, okay, no. Bin noch da. Ja, so in etwa. Kompression ist okay. Morgen Sound. Okay, peeps. Yeah, peeps. See you tomorrow. I will sign off and you can join teaser. Bye bye.